Hello, my name is Francis Hitchens and I'm a Principal Software Engineer at Amdocs. My presentation is going to be about the Vault database plugin that I've been working on for Redis. The plugin allows a Vault secret server to create and manage the entire lifecycle of all or any user passwords and their desired access control lists associated with it in a Redis directory or database. Authentication has existed in Redis since version 1.0 but without TLS, so anyone who could sniff network packets would have been very easily able to look at the credentials and steal them. It was also really easy to perform brute force attacks on Redis. Redis was or is very fast at serving queries, so many different password attacks per second can be done by an external client. This was a well-known weakness, and it was recommended to set the administrator password to be very long to get around that. So of course, anyone using Redis in a production environment had to lock it down using compensating controls like layer 3 networking security. Prior to Redis version 6, there was no support for TLS or ACL-based authorization. Redis 6.0 was released in June 2020, so this hasn't been around for quite a while. It's quite difficult to set up and manage, especially in a cluster, so I think adding this facility to Vault will be useful for quite a few corporate users managing large Redis clusters and things like that. So I'm going to do an overview of Redis for those of you not familiar with it, because it's quite different to a lot of standard databases. We'll have a look at Redis clustering as well, as that's fairly unique. A brief glance at the custom plugin library, but I expect most HashiCorp developers are very familiar with it. Have a look at my to-do list, and I'll try and do a hands-on session using the plugin to show you how it works. Okay, so for those of you not familiar with Redis, I'll try and briefly explain what it is. It's a very fast open source in-memory directory or database or cache that's typically used to store objects by key that you want to access quickly, like session data, and get rid of quickly, and those don't need persisting to disk. It can be deployed in a number of different ways: as a standalone server, as a cluster with automatic partitioning of the keys, or as a highly available Sentinel installation. Sentinel installation I haven't looked at, and I don't know when I'll get round to that, but I don't see that it should fall outside the scope of what we can do with the plugin. Maybe it needs some tweaking, or some different APIs have to be used to talk to it. We'll have to see. Okay. Redis clients communicate using a very simple text-based protocol called RESP, Redis Serialization Protocol, and it's over TCP, and lately you can also add TLS to improve the security. Get and set are examples of REST calls. Get and the key gives you the data back associated with the key, and set sets the key to the value that you want it to be set to. Okay, for the purposes of managing authentication and authorization, the ACL group of commands and their subcommands are used. Here, the ones that are mostly used in the code: the delete user, the get user, the set user. I'm sure you can imagine what they're used for. Users and ACLs and their ACLs are stored in memory only unless you explicitly persist them using the ACL save command. I'm imagining that any real production setting, you'll want to persist users between restarts of the server. So Redis has to be actually started with an actual configuration file mentioned, which can be used to define a specific ACL file to save the provisioned users between restarts. You can use this command that is illustrated here, config get ACL file, to show you whether there is an ACL file configured or not. If there isn't an ACL file configured, but there is a config file and you do ACL save, Redis server will save the users into the config file, which isn't ideal, I don't think. So, you know, you don't have any control over that, and it's not easy to figure out which way it's configured using the commands in Redis. So be aware of that. ACLs are grouped into high-level categories, which is very useful as it allows us to write vault roles without needing to specify every single command that we want to control access to. There are an awful lot of them. Even when they're gathered into these categories, there are 21 different categories. So here, let's take a look at how we can use the categories to declare a vault role that can be used to grant access to a user that's not privileged to use some of the commands categorized as dangerous in Redis. The first line here, ACL set user Karen on, make it active, adds all of the particular ACL roles that are available, but then subtracts the ones that are in the dangerous category. And this can be simply used to write a vault role to do that. The command is illustrated here, where we create the role, set the database name that we're applying it to, TTL max, and we use the existing creation statement with a vector of strings just to put the particular ACL categories or ACLs themselves in that we want to use. Again, we can use the ACL cat command to see what commands are in the dangerous category, and there again you can see there's an awful lot of them. 31 different commands are categorized as dangerous, and user Karen is not meant to have access to them. So when I came to look at writing the client, I had to decide which of the many open source Redis Golang clients to pick. There are 15 of them on the official Redis clients Go page. They're all open source. They all come from different users or groups of users who like to work on Redis clients. 3 of them had gold star recommendations in the Redis page, so I just focused my attention on them. I didn't want to look through all of them. Out of the 3, I found that the one called Radix, which I mention here, looked the best one for the reasons that it had the most activity on GitHub. It natively supported clustering and TLS, and it had the best documentation that I could find with clear examples for me to follow in my code. And the lead developer, Brian Picciano, was very kind enough to answer questions I emailed him, and he actually reviewed my code for correctness in the end, so I was fairly happy that I'd done a good job using his API, or client API rather. So I started working on the standalone server first, and it was fairly simple to work out how to access it. and how to set the user count and password and to provision roles and so on. And the Redis documentation, looking at it, it wasn't really clear how when you moved from standalone to cluster, things changed. I didn't know whether I could just provision to one of the cluster members and it would be automatically replicated to the others or anything like that. And I had to try it out and find out that actually no, it wasn't. I had to go and do the work of figuring out what the topography of the Redis cluster was and going to each of the worker nodes or nodes and repeating the provisioning commands on them. So, and another wrinkle was that if you added a new member to the cluster and didn't re-shard the partitioning of the keys, that cluster member was not considered as part of the cluster. So it would never get provision to a username password that you wanted to be cluster-wide, which kind of makes sense, but you know, you have to be aware of these odd things. So when you configure a cluster in the plugin, as we have here in the middle, you give it a list of the hosts using the cluster equals parameter that you want the plugin to try and connect to, or actually the Radix API call inside the plugin. It does that, and it'll connect to the first available one that works with the configurable timeout, and then you move on from there. So this example shows me configuring a database called my cluster. The cluster host has host 1 and host 2. We pass it the account that we're going to use to do the provisioning inside the Redis cluster, and we give it a persistence mode of use the ACL file, which we'll talk about more in later, and pass it the CA cert needed to connect securely to the cluster. Within the plugin code, we use this topo method to return the actual cluster topography, regardless of what's mentioned in the list here. In order for the plugin to provision the same user to each cluster member, it has to go get that topography and iterate through each one of the members in the list and apply the provisioning commands on each one in each host in that list. This is just showing you the Redis cluster nodes command brings you back this detail about the cluster. It's got some kind of internal serial number, and then you've got the IP address and port that each one of the members is listening on, and whether it's a master or a slave, or on which one is myself, the one I've actually connected to, which you can see third line down, I think. Okay, so calling the topo method in the Radix API hides all these details from you and just gives you a nice list of host and port for you to iterate through. We can possibly look at that code later. The custom plugin library, just for everyone's knowledge, it was written using the version 5 interface, which is the one supported now by the latest version of Vault. It's much more simple. It's been simplified compared to the previous plugin library interface. It's got many of the overlapping duplicate methods removed, and we only have to implement these particular methods now: initialize new user, update user, delete user, type, and close. Much simpler. There's no rotate user, which is really just a call underneath to update user. So it's streamlined, easier to use, and much nicer. These are the things I still need to do. There's a sort of sister Spring Cloud Vault config project that supports accessing databases with credentials from Vault through the Spring Cloud framework. It's already got support for Cassandra, Couchbase, Elastic, Mongo, MySQL, Postgres. I need to do the same for Redis. It's not difficult. I don't really like working with Java and annotations all that much because they're very opaque, but I'll try and get round to that in the next steps. Okay, so I think that wraps up more or less what I wanted to do as a do as a presentation, and we'll try and move on to a demo of the plugin now. So I wanted to start the demo by just briefly looking at the Redis client that I used, and in fact we used version 3 of it, version 4 still in beta, and I just wanted to show you that it's nicely documented with plenty of easy to use examples, very helpful, made it easy to do. So now let's switch to looking at my own Vault plugin repository. Standard layout, like all of the other ones, has information on how to build the plugin, how to install it, how to initialize it against a standalone or cluster instance, and some examples of dynamic and static role creation. So let's go back up to the top and have a look in the main Redis Go program file. And in particular, I want to focus on the new user method, as it's very illustrative of all the other ones. So, of course, we start off as usual by getting or creating some credentials, getting a connection to the Redis database or cluster, and then using a helper function to do the actual provisioning. So let's go and have a look at that with more detail. And you'll notice when we're there, the first thing we do is format the commands that we want to fire off. It's a vector of strings that create the user, turn it on, and set a password. Here it's the generated password. And then the next thing we're going to do is take a look at the kind of connection we've got. If it happens to be a standalone connection pool, we're just going to go and fire off the command once to the Redis database. Otherwise, if it happens to be a cluster, then we've got a bit more work to do. We need to get the topography of the cluster and start iterating through the nodes, and again firing off the user creation command on each individual one, and then persisting the changes if it's successful. And in fact, we persist the change 2 on the standalone instance. So that's a very common pattern for all of the other functions. So now I'm going to move on to running the test suite for the plugin. This first run is going to be using the code that spins up a Redis Docker container and connects to it and runs all the tests against it, where of course it can't persist any of the settings as there's no configuration file. In fact, it tells you there if you see. Now I'm going to export the environment variable to start using TLS, and the next one to export the cluster hosts. I'm only going to connect to one local host, and from that the test suite will pick up all the rest of the clusters and start provisioning accounts to the various cluster members, which is handy because I can then use the administrator username password to spin up the Vault plugin in the next part of the demo. So as soon as this is finished, we'll move on to that. This time it's running and it is able to persist the changes that it's making. You'll see that it doesn't say otherwise, I hope, at the end. That done. Alright, so now let's have a look at the plugin integration with Vault. I have a script here that I'm going to use to shut down an existing Vault server, spin up a new clean one, and then we're going to copy the plugin into the plugin directory. We're going to then go and generate a checksum for it. We're going to enable the secrets, the database secrets engine, and we're going to register the plugin in that secrets engine. And the next step, I'm going to generate a environment variable with a CA cert in base 64 encoded, and I'm going to use that to feed into the Vault initialization of the plugin here, and it's going to create a connection to the database. We're going to use the cluster address. I think we've got 2 members in the address. It'll go to the first one available. Here's the administrator password that we created in the sanity testing that we did before. We're going to persist to the ACL file, use TLS, and there's the certificate being passed in. And in the next 2 steps, I'm going to create a write role for the foo key and a read role for the foo key as well. And then we'll do some other things with those. So let's come out of here and execute the script. And let's hope it goes flawlessly. Then we'll be in a position to start using Vault and the Redis plugin. Okay, so before I do that, I'm just going to check and make sure that I've got the roles that I need, or the account set up correctly. Just a quick script to list the users on each of the Redis databases ACL file. Yes, I can see the administrators set up in each one of them, and if you'll notice, this is the default user that has privileges and no passwords, and of course as soon as we've got it managed by Vault, we really want to think about getting rid of that one and letting Vault rotate the admin password and making things more secure. Okay, so now I'm going to go and sign into the Vault console with the root token, and let's go have a look in the leases and see that it make sure it's empty. Good, nothing there, so we'll go start creating some. Alright, so let's do a PS command, and from the output we can see that we've got the Vault server running, and it has successfully started the plugin to connect and communicate with the database. So let's go grab ourselves some read let's get a read role now. And here's the username password. So I've got a script to simplify testing. Just pass in parameter number 1, the username, parameter number 2, the password, and the subsequent parameters are the Redis commands I want. So I'm going to try get on the bar key, and yes, I don't have any permissions to access it. So let's try get on the foo key. And that worked, even though nothing came back. No security violation. So let's check, use the ACL file and see whether the the username's been provisioned everywhere, and yes, I see it in all 4 of the cluster members. Okay, so now let's pop into the Vault console, database, credentials, read role. Oh, there it is. Let's revoke it. Okay, gone. Back to the command line. Let's execute that check again. And oh yes, good. We've managed to remove all of those usernames using the Vault plugin. So now I'm going to get myself a right credential. From the right role. Again, username and password generated on the fly. I've got my set script to simplify the test. Let's pass in the first parameter, the username, the second parameter, the password, and now we'll try and set a key to a value. That's when my fingers start working. Set XXX 999. Okay, and no permissions, no surprise there. Let's try it on the one that we have access to. Okay, that worked fine. Let's set the other one, the bar key, and let's be original and set it to foo. Jolly good. Okay, so now let's go grab a read credential and try and read that, make sure it actually worked. Jolly good. So let's try and get the key that we're allowed to read. Username, let's pass it in. Password. Jolly good. And get foo and 999. Success. The Vault plugin has been able to do its job. Okay, so my final trick coming up now. Let's check the user password, the administrator password. It's the same on each machine. So let's go rotate it now so that we're nice and secure. Rotate the root password for my secure REDIS. Done. Check the passwords again. And you will see they've changed and are known unto Vault itself. So here endeth my demo. I hope you weren't too bored. Thank you.